Okay, good day. This is Math 140 College Algebra. I'm Professor McCulley. This is the lesson 4-2 on polynomial factoring. Let's get right to it. Today we're going to factor polynomials by removing common factors. We're going to factor special polynomial forms. We're going to factor trinomials as a product of two binomials. And we're going to factor polynomials by grouping. So let's talk about those special form factoring difference. And if we're going to kind of talk about two special cases here, we definitely want to highlight difference of squares. This one becomes very important, and difference of cubes. These two are also going to be very important. If you don't know your perfect square trinomials factoring forms, that's okay. They will become evident in regular factoring if you use the process that we learned in the last unit for factoring quadratics. So that one is not nearly as important. So let's move on. Factoring by grouping. Factor by grouping, a special case factoring method that involves a polynomial of 4 terms. The first 2 terms and the last 2 terms must both have a common factor. So when I look at this example right here, I've got 4 factors here, or 4 terms, excuse me, and I'm going to group both the first and the second 2 terms. So this first group is going to be x to the third minus 2x squared. And then I'm going to bring down this minus, and I'm going to put a parenthesis around these two. But here, I'm making this into a quantity unto itself, and I want to subtract away the whole quantity, which means if I were to get rid of these parentheses here, I'd have to distribute the negative to both sides. So when I put the parenthesis around here, this actually becomes a positive 4x. And this one, though, has to also change its sign and become a negative 8. And so when I subtract this whole thing away, I can distribute the negative here to get the negative 4x, and I distribute the negative here to get the positive 8x. Now, at this point, I want to factor common factors. All right, so I look at this one and I say, what is common to these two terms? Well, in x to the third and 2x squared, the greatest common factor to these two terms is x squared. So I'm going to factor out an x squared. And when I take x to the third and I divide out an x squared, all I'm left with is just an x. And when I divide negative 2x squared by x squared, I'm left with just 2. And here, I look at these two terms, and I notice that in 4x and 8, the greatest common factor is a 4. And so when I divide 4x by 4, I'm going to get just x. And when I divide 8 by 4, I'm going to get 2. Now, this is important because you will notice that both this term right here and this term right here are the same. If that is not the case, then you've either made a mistake or you cannot factor by grouping. And so here we're going to factor out the x minus 2. And so I'm going to put that here, x minus 2. And when I factor x minus 2 out of this first factor, I'm left with just x squared. And when I factor out this x minus 2 from this second term, I'm left with just a 4. And usually I'd say we would be done there, but I do notice that this is a perfect square and this is a perfect square. So if we go back up here to the difference of two squares, if I have a term squared minus another term squared, then I can factor that into a plus and minus. And so this thing right here is indeed x squared minus 4 is a difference of squares. And so I have to go x minus 2, and then this thing factors into x minus 2 and x plus 2. Now you're allowed to leave it like this. For me, I've got no problem with that, but if you look in the back of the book, you might sometimes, or back of your book, you might sometimes say, well, this is an x minus 2 and this is an x minus 2, so it's the same factor. And so they might rewrite it as x minus 2 quantity squared times x plus 2. and that is also acceptable. All right. So if we're going to do any kind of guidelines for factoring out polynomials, the first one that you always want to try, and sometimes it doesn't work and sometimes it does, but you always want to try and factor out common factors first. That is the first thing. Then you want to look for one of the special forms. Factor as if it were in binomial or quadratic form, and then factor by grouping. So let's look at some more examples and see when we can use those guidelines. So what is the greatest common factor of the following polynomial? If I look at this thing here, I'll have the greatest common factor, and that's all we're doing for this one because that's all the directions ask. If I look at these things, I see 3 divides all 3 terms, but I also see that z divides all 3 terms. So the greatest common factor of this particular polynomial is going to be 3z. That's going to leave me with z to the third minus 2z, and then plus 3. And this, whoa, I have a 6 there. I said it right, but did not write it right correctly. So let's fix that, because 3z divided into 3z to the fourth is going to be just z to the third. So that was a mistake on my part. And I think that's all I'm going to be able to do with that one. So we're going to leave that one alone and move on, because I think this thing is going to need a quadratic formula to get zeros out of that one. All right, factor the following polynomials using a difference of squares. So we're using difference of squares, and we remember that the difference of squares rule is a squared minus b squared can be factored into a minus b times a plus b. So when I look at this thing, I don't see right away a difference of squares. So the first thing I want to do is I'm going to do a GCF first. Oops, let's go GCF. All right, we're going to do a GCF first, and the greatest common factor between these two terms is going to be 3a, and that'll leave me with b squared minus 4a squared. And so in this particular instance, my leading square is b squared, and my finishing square is going to be 4a squared. So the square root of 4a squared is just going to be 2a. So this thing's going to factor into b minus 2a and then b plus 2a. And that is a bunch of linear factors, so we're going to leave it like that. Next, use the sum or difference of cubes to factor the following. So again, I'm going to look at this thing, and the first thing I want to do is I'm going to try and use a GCF. And I notice that 4 divides both of these, so I'm going to divide the 4 out. And I'll have b to the third minus 8a to the third. And both b to the third and 8a to the third are cubes. So b to the third and 8a to the third are both, let's get rid of that pointer, are both perfect cubes. And since they are both perfect cubes, this difference of cubes term says that if I have u to the third minus v to the third, I'm going to get u minus v times u squared plus uv plus v squared. Okay, we can do that. So if v to the third is going to be b to the third, then we can say that just v is going to equal b. And if I say u to the third is equal to 8a to the third, then just u is going to be 2a. And so 2a times 2a times 2a will be 8a to the third. So when I use that special property there, that v to the third minus u to the third equal to u minus v times v squared plus uv plus u squared, like that, I can rewrite it. I still need this 4, so I'm going to write that 4 there. And then it's going to be, oh, what a mess. Sorry, I didn't mean to be confusing there. It's going to be v minus u is that one, and that does match what I have here. So I apologize for that. So we're just filling in the blanks. That's all we're doing. Since my v is b, we'll put a b there. Since my u is 2a, we'll put a 2a there. And then v squared, well, b times b is going to be b squared. uv, so 2a times b is going to be 2ab. And then 2a, u squared, 2a squared, 2a times 2a is going to be 4a squared. Now, this thing tells me that this is the smallest I can factor this. This thing right here, this part right here, is irreducible over the real numbers. So since they're not asking us for solutions, they're just asking us for factors, we're going to leave that alone right there, and we are going to stick with this as our final answer. All right, getting down to the last one. Factor the following polynomial by grouping. Well, you'll notice that this one is listed from least degree to highest degree, and normally we wouldn't put it that way, but we have this negative sign out front, so we're just going to leave it like that. And so we're going to group terms, let's do it right, 1 and 2 and come on, Macaulay, get with it, terms 1 and 2, then 3 and 4. So I'm going to go 5 minus x, and then plus, it'll be 5x squared minus x to the third. All right, so we're going to remove greatest common factors from my spelling is awful today. Each group. Going to remove GCF from each group. And all right, so we can do that. Now, this one, though, I look at the 5 and I look at the negative x, and there's nothing really common there. But I also see a 5 and I see x is here, so I think I'm still going to be okay. And just as a placeholder, I'm going to place a 1 right there, because I can't really factor out anything from there. So I'm going to have a 1 times 5 minus x. And then I look at these two terms, and I see that I can have an x squared. And this really should be a plus. And so I'm going to factor out that x squared, and I have 5 minus x, which is good, because you notice that 5 minus x, I can factor this thing by grouping. I've done it right. And then I'm going to factor out the 5 minus x, and that'll leave me, I'll get my 5 minus x out front, and then I'll have 1 plus x squared there. Now 1 plus x squared is also irreducible. And the reason that we know that is if I set this thing equal to 0. So why? If I go 1 plus x squared and I set that thing equal to 0, I get x squared equal to -1, and I get x equals plus or minus the square root of -1, and we know that that is plus or minus I. That's imaginary. So I cannot factor this any further over the real numbers, so that is going to be my final answer right there. And that's all I got for today, folks. So today's Marvel fun fact of the day: the Black Widow character has been in the MCU since Iron Man 2 in 2010. The solo movie Black Widow was released in 2020, but it is set after Captain America Civil War, which is in 2016. So after Endgame, there's a lot of time jumping around, and you have to kind of pay attention. But I'm sure back 20 years from now, when we're rewatching all these movies, we'll just watch them in chronological order according to the MCU. That's all I got for today, folks. Have a good day. Bye.